All right, welcome back. Okay, this is going to be the only seminar that is going to be recorded. Okay, that's because I'm speaking. The other ones, you are going to be talking, so I'm not going to record it and put it online or something like that. I guess you are happy about this solution, okay? So you will need to be here. Anyway, so let's very briefly explain the seminaries and what they're for. So these are the goal of this seminar in an order of the overall lecture. So you're going to learn about current cosmology. So it's going to be like up-to-date stuff, so current literature and so on and so forth. You are going to not only learn from the others, but you're also going to teach to the others, because whenever you're going to take a paper of your choice, you're going to explain the topic, okay? And me, the others, are going to learn what you are going to present. You need to develop skills in presenting science, and this is crucial, because whenever you are going to do research, if you want to continue as a researcher, but even for the master, you know, if you're also doing the masters, you'll be able to present and produce a scientific paper, and this can happen. Then you will need to explain to other scientists what you did, okay? And therefore, you need to learn how to do that in an efficient way, okay? Then you have to learn quickly and efficiently, in the sense that I already mentioned it earlier. There are going to be a lot of papers that are going to be produced on a daily basis. And you need to learn how to distinguish good paper from bad ones, or let's say papers that are not worth to be read or that you can skip, okay? So you need to be able to spot what is necessary and the message of the paper in a very fast way, okay? This doesn't mean that you will be able to do the computations. This you do it once, okay, say, okay, this is a good one, I want to continue this research, then you do the math, okay? Gesundheit. Otherwise, you just, you have your paper, you can go through it, see the key points, and get the message of the paper, okay, and get the physics out of it, okay? Good. Then you have, yeah, as I said, you have to, that's already said, basically you kind of, through this shallow understanding of a paper, you need to spot the key points. So that's important. And perhaps kind of key to most of you, you need these presentations, because that's the way in which you can pass the exam, okay? Your presentation is going to be your exam. The way you present the paper that you have chosen, how you discuss the physics, if you just do, you know, blah, blah, blah of mathematics, or if you also give the meaning, and so on and so forth, if you can put it in a context, and so on, all these elements are going to be used to evaluate if you learn how to deal with physics as a scientist, okay? So understanding of the concepts, understanding of the mathematics in the sense of the structure, and if they use the right mathematics to approach a problem. I gave you earlier an example of the Fourier transform, which they should have used different approaches. So you see, even if I didn't do the math, I know that this was not ideal, okay? So you need to learn this sort of skills. And of course, advanced topics in cosmology, in the sense that the topics that are currently discussed in the literature and among people. So this is the format of the seminaries. I'm going to compile a list of papers. So these are suggested readings that are coming from the last 10, even 20 years, because there are papers that are still relevant, okay? It's not that they are written and then the physics expires. If they're good, and their science remains, okay? So you have this range of papers that you can pick up. You can work in pairs, and actually I suggest that. So if you have some other people you would like to work with, do that, because you will understand something that the other will not, and the way around. Okay, so interaction and talking helps a lot in better understanding the topic. So you will work in pair, but each person is going to give an independent presentation. Okay, so two people perhaps working as a team for a paper, and one present some aspect of the research, and another one on something else. okay, or continuous, or parallel topics in contrast. That's up to you how you want to structure, okay? So you're going to have 25 minutes to talk, so you need to be, you see, efficient. You need to be fast in delivering the message in 25 minutes, okay? And keep in mind that you might have interruptions, because people can raise the hand and say, but what is this, what do you mean by blah, blah, blah? Okay, so keep in mind that you have a budget to account for when you give your presentation. This is the list of topics that are going to be, that you can present, okay? So you can see, I don't know, dark matter in numerical simulations, dark matter from a particle point of view, dark energy, Lyman alpha forest, I don't know, variogenesis, galaxy cluster, cosmological probes, and blah, 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 okay? So there is a long list of papers that you can pick up. How to select them? It's going to be easy, because you can be curious in a topic, you have your papers, and you will see if you are attracted by it while you're reading it. For example, I remember when I was a student and I had to select my topic, I went to two professors, they gave me one paper each, and for one professor, I went through it, then I got other stuff, I read. The other one, I didn't manage to go through the abstract. Okay, I was like, I will read it later. Okay, so keep this as a criteria to select the topic. Okay, you need to be curious about the topic such that you can push through it. Okay, good. The elements of the seminar, you have to, as I mentioned already, you have to spend your time to identify in the paper what is really new with respect to what was coming from previous research. So spot the new stuff, find what is important about all the different topics, because there are going to be a lot of technicalities, and you need to skip technicalities and give to favor the concepts and the physics which is expressed. Okay, there are papers that are 90% technicalities, a little bit of physics or physical understanding. Okay. In other cases, cases, the technicality must be the point of the paper. Perhaps it's the point of the paper, because maybe they are producing a new methodology to perform some observations or to solve some equation. So the technicality is the subject of the paper. Okay, so take care of that. Okay, and select the papers that are likely to be correct. Okay, so you need to be critical when selecting the papers. Okay, the list that I give you are kind of well established, so you can you don't risk much. But if you're going to pick up other papers, or you start from the one that are proposed and read other papers, you need to be critical with the reading. Then, when you want to present give your presentation, and especially when you are preparing your presentation, you have to find out basically what is the question of the paper. So is it more about the methodology, or is it more about the physics, or what? What is the true point, the question that they want to solve? Is it observational? Are the observations that they use are solid, they are not, and so on and so forth. And of course, you can extract plots from the papers. Okay, this can be helpful, because if you want to show the behavior of some function, or if you want to see what is the scatter, what are the scatter of the all data with respect to your model, the prediction, and so on and so forth, that's good to see that. Okay, and you will see there are going to be a lot of plots in a single paper, and you need to pick up the interesting ones. Some are for testing to show that what you're doing is correct. Some are, okay, that's our result. Okay, so you need to understand what are the plots that are relevant for the little time that you have available. Okay, so you need to select that. Then the paper, your presentation, basically how you should structure your talks. So you need a sort of a punchline, like we are going to talk about that. Okay, and when you do that, the one thing that you need to do is to keep in mind to whom you're talking. Okay, that's important, because you might go to a conference, okay, and the conference might be generic. Maybe it's about astrophysics and cosmology, and there are people that are dealing with astrophysics, I don't know, formation of galaxies, or I don't know, planetary system, or whatever, and are not experts in cosmology. So you need to give and structure your presentation such that also these people can follow. Okay, so you need to give a broader overview of why you are doing what you're doing. So that's, you need to set the stage and the punchline, what you're doing and what is it for, and then you can go gradually into details. Okay, such that people can follow. Maybe they will not understand everything, but they will understand the 3 points that are relevant for your talk. If you're going to a conference which there are splinters, meaning it's not everybody in the same room talking about a large variety of topics, but there are sessions which are focused on specific topics, and therefore very focused, the audience will be composed by experts of the field. And you don't need to introduce cosmology. Okay, you don't need to explain, I'm going to do cosmology, lambda CDM, blah, blah, blah. They know. Okay, so you don't need to explain them that. And you can go straight to the point. Okay, again, you give a little bit of context, but then boom, you go straight to the point. Then you need to explain, as I said, if the paper is about calculations, so if there are new mathematical approaches that are used, a new idea, for example, I don't know, emergence gravity instead of some other theory of gravity, so you make clear what's the idea of the paper. If you're going to use new data, or if the data are from the archive, or if you're using a collection of different data. And therefore, if it's more observational or what, and technological, if you are going to use, again, something that is related to new instruments, for example, and then if the instrument is new, you will need to explain to the people what this new toy is doing, okay, how it works, and so on and so forth, okay? Then what are the broader implications of the results? So you need to explain and filter through what the authors are going to say. So again, critical you have to be. They are going to say, our results are great for this, and that. Then you can say, okay, the authors are stating that all of this is possible to be addressed with their science, but you have to be critical. So you have to filter through your own judgment. And you then have to say if the paper have been clearly presented. So if all the arguments have been clearly presented, because there might be cases in which they did the analysis, but something was not explained, or something was purely explained, okay? If it's persuasive, so if they are convincing, so that's quite related to that. If there are speculations, or there are kind of concrete results that can be proved with observations, and therefore they are useful. If there is just speculation, okay, you can speculate whatever you want, who cares, okay? It's not, it's science fiction, okay? We don't care about that. And then, yeah, that's it basically. If it's innovative, you know, but if it's, you should pick up something that is innovative. Okay, if it's a paper which is just reporting a little bit improvement with respect to the previous one, is not the previous result is not an interesting paper. So that's kind of obvious. So as a preparation, keep in mind that it takes time. Okay, to prepare a talk, it requires time, especially if it's the first time that you do it and you don't have material that has been already produced for other talks. Okay. Just after you have understood the topic, reading the papers, understanding what they're doing, and all of that, keep in mind that to put together the materials might require you 2 or more weeks. Okay? So it takes time, because you will have to rearrange it, compress it, choose the plots, and all of that. Okay? So it takes time. Don't take it easy, especially because the mark is based on your presentation. Okay? So prepare it very well and rehearse it, okay? Once you've done your presentation, you have your slides, and your presentation might be at the slides or at the blackboard or both, okay? It's up to you to choose according to the material that is contained in the papers. So you need to select the media which is more useful to deliver the message, okay? Good. Okay, then the references have to be all given, and when you start, you have also to explain if this is a review paper, which is just which is not new science, but is basically are big papers that collect the science that have been produced earlier, and they make order. Okay, they make a summary and they make order and give a broader overview of the status of the art. Okay, these are called review papers. They can go up to 100 pages. Okay, they can be little books. Okay, typically scientific papers range between 10 and 30 pages, something like that. That's the typical size. These are a few examples of one of the topics. For example, these are Sunyaev-Zeldovich effect. That's one of the effects that are visible in the cosmic microwave background discussed during the lectures in cosmology. And here there are a few papers about this sort of data sets. Can be observation, you see, based on the South Pole Telescope, where you can find out on the website of the instruments the literature that they suggest. So these are going to be their key results. So they are relevant. So also websites are interesting. And a few, and several others, okay? So there are observations done, carried out with different instruments, different approaches, different methodologies, and so on and so forth. So don't look only at the list that I'm going to provide you, but also look in ADS, okay? ADS is a portal in which you basically can find all the literature, okay? And if you are in the campus, if you are like Eduron, or if you are here connected to the VLAN or something, then all papers are accessible to you. Okay, some papers are going to be available only on the archive. I didn't write it here. That's so there are basically two main portals to look for paper. One is this one, ADS, where there are all the papers that have been also published, okay? Because typically scientists produce their results, they write it a paper, they put it on the archive, and that's open, okay? There is a gross selection from the people managing the portal to select papers that make sense, because there is a lot of crackpot going around, people who say, oh, Einstein is wrong, you don't understand anything, that's the truth. And I receive like 1 or 2 emails per week of this sort of people, and therefore there is a pre-selection on the archive, but it's pretty clean, okay? And these are papers that are not accepted on journals, or they are not yet accepted on journals. So people write the paper, put it on the archive, there is the referee reviewing of the papers through the journals that can take 1, 2, 3, 4, 5 months, and then they get published and you find them here. So start first to look here, because here they are already cleaned up through the referee report, okay? Therefore, the papers are of a better quality, and you can type whatever you want. You can type the argument through the title, you can search for authors or whatever, and then you have the entire literature, okay, up to date. On the archive, you have it daily. Every day on the archive, you see what came out today, tomorrow, blah, 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 and so on and so forth, okay? So keep in mind this web page, this website. Then I will also add the one of the archives. Good. Yeah, check. I mean, pick up your topic. Not much to say about that. And since the number of topics is finite, as is your number, okay, the first one that select a topic, get the topic. Okay, as soon as I put the list on the web, I will tell you, look, the list is on the web, pick up your topic, and then through Doodle, you will put your name. You put your name, and the topic is yours. Okay? So be careful in your selection, and the first arrives, first served. Okay? The grade of the entire lecture, so lectures plus seminary, is of 4 points. And the regular attendance to the seminary is mandatory, because what you're going to present to the other students, to your peers, is relevant. It contains science, and that's stuff that you need to learn. Okay? So that's mandatory. You can miss one, okay, but you need to explain why. I went to the doctor or something. We know life is complicated. It can be that on Friday afternoon after lunch you have to do something else that you cannot escape. Okay? But you need, you need to explain why this is happening. The schedule is this one, so the first one is today, you're here. And then May is going to be free, and the next one is going to be at the beginning of June, and then it's going to be every day once you filled up all the slots, okay? So your slots are going to define when we are going to have a seminar, and the time you already know, okay? So after the seminar, the presentation, the question, and so on, we can have, you've seen like 25 minutes, there might be room to discussion, okay? So we can have a broader discussion about the topic that was covered without the pressure for the speaker to feel judged because of the exam, okay? So when the seminar is over, that's the judgment, the rest is discussion to better understand the topic, okay? All clear? Okay. Then, after the presentation, you select the topic, you prepare your slides or your notes to present at the board, how to give a talk, okay? As I said, think at the audience that you have in front to tune the speed and the argument and that you need, and the width of the overview that you have to give at the beginning. So this is extremely important. So you have to keep in mind what they already know, such that you don't bore them, because otherwise they get bored. Then the first and the last slides are the most important, because the first one, people is still awake, for sure, okay? And they need to understand what is this talk about. So they need to have a clear picture of what you want to talk about. And the last one, because if they fell asleep during the talk, they wake up at the end, and there must be summarized the key point of the talk, okay? So first and last slides are, or the beginning or the end of your talks are the most important ones, okay? Select a few topics. I mean, keep in mind that when you have a paper, you would like to put in all what you learn, okay? You will feel this instinct, but I learned this, I want to say, I want to say. Don't overload the talk, okay? People typically can deal with 2-3 messages in one talk. The rest is going to be forgotten, okay? Or is going to make just confusion, okay? And you see that that's this is 0-1 is a kind of harsh, but is not far from reality. So if one is really taking care, 2-3 points are taken, the rest is forgotten. Okay? Good. Then, a clear explanation. So, how to give a clear exposition for scientific issues? You need to, well, I already said it. No. Well, it is already said it earlier. So, make it clear what is the point, why is it interesting, so the reason why all of that is important, and state the obvious, okay? But only briefly. You can also say obvious things, but say it briefly, okay? And that's needed if you have especially if you have a broader audience. To you, it might look trivial. I've seen talk where cosmology, yeah, sigma 8, blah, blah, blah. Questions, what is sigma 8? Okay, so, you know, is obvious for you, but not for everyone, okay? Then practice your talk. So once you have it, prepare it, rehearse it, rehearse it, rehearse it. And when you do it, speak loud, okay? This helps, because if you have in mind, you end up earlier, okay? And then you mistake the timings. And keep in mind that when you give the talk, typically it takes longer than when you rehearse it, okay? Okay, then using a presenter is useful, like this one. Okay, now I'm not exploiting it because I'm far and I cannot see it. But you see, you basically have you can basically see two things. One is the current slide, this one, and this is the one that is coming. This helps you to keep a fluent stream. Otherwise, you can see many times people that finish a slide, like also I'm doing it now, put the new slide, and then what was that about? Yeah, and then continues, okay? So presenters such as this one helps, and also for PDF. So if you're going to use LaTeX or something to make your slides, there are also presenters for PDFs, okay? I think is like in Linux is PC, I don't remember, how we write it, PDF PC or something, or PC PDF or something like that. Yeah, exactly. PDF PC. Okay, so even for PDF, this works. And tend to put all your names on all slides, because you can give maybe your talk is interested and is interesting for someone, and then nice, this was interesting, and then who was this guy? Okay, maybe he even knows your paper, but it's not your face, is not attached to the paper, is not attached to the science, and therefore it's important that you put your paper on each slide, okay, such that people can also search for you while doing the paper. Okay, well, who did this guy? What other paper? Blah blah blah, and so on and so forth. Okay. Then the timing is important, because especially nowadays the timing is becoming extremely strict. Okay, I remember at the beginning we were supposed to finish at 5. In the end, the conference was finished at 6:30 or something like that. Okay, because everybody was still in 5-10 minutes. Okay, now it's not anymore the case. It's typically very strict, and it's not rare that you're going to get also 10 minutes to talk. Okay, 10 minutes plus 5 of questions. Now it's quite common. Back in the days, you had your 45 minutes kind of all the times. Now it's really, you're really on the clock. So do not lose time at the beginning, and this is typical, that you see talks in which there are a lot of blah, blah, blah at the beginning, and then in the end, when you are at the core, you need to skip slides or you need to speed up. When you actually there was the moment to slow down and stress the points, okay? So especially when you rehearse it, be sure that you're not losing time at the beginning. Make yourself, for yourself only, some sort of time mark, okay? Like on this presenter, you can see the time running. And you know that at slide, I don't know, 10, just to say a number, you should have done 10 minutes or 20 minutes, okay? Such that you see if you are too slow or too fast. Because everyone can also be too fast, okay? Also excitement, one start to speak very fast, okay? So you need to see, to put some intermediate steps such that you see what is your actual pace. Then you need to understand before the talk which are the slides that can be sacrificed. Because if there are a lot of questions, maybe you are perfect in your presentation, but people are slowing you down because they continue to interrupt you. Okay, this can happen. And then you need to know which one are the slides that you can skip. So you have your presentation, and you can say, okay, this one I skip because the time is, yeah, and you go to the next one. And you say it is not relevant, it's not that relevant, we can skip it, and you can continue. Okay? So keep in mind that there are slides that might be skipped, but you need to know it ahead. If you improvise, then you mess up yourself, you get nervous, and all of that. Never, ever run, as I said, over time, because otherwise they will literally cut your talk. Okay, they will tell you, look, we need to conclude, you have 2 minutes, and you need to rush to the end. And you need to be sure that, that you arrive within the time, and never think, I think I'll stop here. Because then you give the message, I didn't tell you what I was here for. Okay, because you need to truncate your talk, and you didn't give the message. And people say, okay, thank you. Okay, so I think I'll stop here, don't say it. Maybe say it, I gave all what I wanted to say, I conveyed all the message, and, just don't be sort of negative with respect to what you did. Or I'm running out of time. Again, I was too slow. This sounds like that. So, use figures, favor figures with respect to equations. If you have talks which are equations, 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 it will be very hard for people to follow. Again, because if it's a one individual seminar, you can do it, because people is fresh, arrive, listen, go through the equations, and then go away. If you are on a conference, and you are hearing people talking all day long, at a certain point, you saturate. And therefore, to go through detailed equations, derivations, is going to be extremely inefficient. Okay? And people do not care about how you go from the initial A to B, all the steps, because it's just mathematics. Nobody cares. Well, nobody cares. is less relevant with respect to what you want to do, which is to say, I started from here, and that's my result, okay? Technicalities can be skipped. So be very careful with the equations. Try to avoid them if you can, also because they take a lot of time, okay? If you have an equation, you need to explain this term means this, and that. This one, blah, blah, blah. And each term has to be explained, okay? And this takes a lot of time. So if there are figures popping up from equation, show those ones, that ones, okay? Because the figure is the final result of your sizings. Take care of the axes. If you do them yourself, it's easy because you can adjust the size of the axis as you want. But if you're taking them from papers, when you put them here, maybe you want to put four plots in one slide only, and the axes are not legible. Okay, the audience, what's on the x-axis? I don't see, I don't know. Therefore, I don't know what's the meaning of the plot. So take care of that, okay? There are stupid things, very trivial stuff, but it's important because it means people don't understand what you're doing, okay? So you have to make the axis large enough. Don't show dense tables, like, I don't know, catalog of clusters or something, and there is a gigantic table with a lot of entries. Or you have a family of dark energy models you want to present, and there is a long list, like a phone book, okay? Don't do that. People just get lost in doing that, okay? The equation that takes time, I said it already, okay? And you need to explain everything which is on the slide. If you don't need to explain something which is on the slide or on the blackboard, it means that it should not even be in there in the first place. It was not something necessary, okay? So if it's on the board or on the slide, you explain it from top to bottom. Equations, I said it, so be careful with the equations. Use readable font size. Colors sometimes are helpful, but don't make, don't overdo, okay? Don't get all colorful mega stuff, because then they lose their meaning. There are colors all over the place. And maybe one color because you want to say useful. You want to stress this word, okay? Okay, good. Good, and summaries, yes. And if you have, you're going to have, a long talk, this is true especially for long talks, identify blocks, okay? Such that you do a block and then you can summarize what's the point very briefly. Block and you summarize. People will remember the summaries, okay? So divide in blocks the talks if you can. How to deliver? Now, these are kind of sociological studies. We are humans and we communicate one with each other. And face expressions, how we move and all of that is extremely important, okay? So if you are stiff, I'm sure you have seen lectures in which, the lecturer was like this and then talk to himself, giving you the back, okay? Maybe even being in front of the equations writing, arrive at the end and then continue talking to himself. Okay, it is extremely tedious for the one who are trying to listen at what is explained, okay? So don't read the slides, talk to the people, okay? The slides should be known to you, okay? You can point to stuff, of course. There are moments in which you can turn the back, but tend to face the audience, okay? You are talking to someone and look for eye contact, okay? If you are talking to people, okay, he's talking to me, he's talking to me, okay? So try to look at people. Try to smile, okay? You might be nervous, don't get kind of an hysteric smile, but I mean, just be normal, relaxed. People tend to be friendly, okay? So don't be scared if you're in a big audience. It can be that you have like 100, 200 people in front of you, can be intimidating, but they're all relaxed. I mean, they are just standard people, no issue. But you can also expect some aggression. Okay, this can happen. This can happen that somebody in the audience can say, come on, you cannot, blah, 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 and kind of aggressively attack what you did, or stress some points, but then maybe he's right. Maybe he or she is right in saying that this is wrong, because maybe something was overlooked. It happens. And can be said in a quite direct, sort of aggressive way. okay? So don't get scared by that, and if there was a mistake in the science, or you don't know, so, well, I'm not sure about it, but I will look into that, thank you, okay? This can be, okay? So also be ready to sort of aggressions or also heated discussions. I mean, I've seen the chairs, you know, are those that are managing the audience and the presenter for the timing and everything to stop a person because he was not stopping to, you know, with his aggression. That one was an aggression to the speaker. Okay, so be ready for everything. Good. Yeah, face the audience, all of this I said. You can have animations, and they can be useful, for example, if you want to see, no, I don't know, you have a potential which is evolving as a function of time. You can explain it, but if you make an animation, people just see how the function is evolving as a function of time or some other parameter. Okay, so they can be useful. Or if you are producing numerical simulations with cosmic structure formation, and you want to show how the structures are moving, what's happening, you can show a movie. Okay, don't overdo with that, because again, they take a lot of time, and if while you are speaking, people look at the things moving, okay, and they are distracted. Okay, so try to explain what's going to happen before the animation is starting, such that people already know what to expect and then see it happening, and then you can again re-explain what's happening while it is happening. Okay? Good. And then avoid dense slides like these ones, because people tend not to read. Okay? And if there is too much stuff, like in this one, you lose the point where I'm talking. I'm talking about this one, or I'm talking about this other point, or what. Okay? So avoid, this is a bad example that is good to see, avoid slides of this sort. Okay? And try to use as little text as possible. Made mistakes, I said, and get a recipe for possible aggressions. Okay? Good. But most importantly, for what you're going to see, have fun with it. Okay? It's nice, you're sharing your experience, what you learn with the others, and it must be something fun, okay? And is useful, also because if you are preparing something that has to be explained to something else, this helps you a lot to really understand what you're doing. If you are on yourself and you do your stuff by yourself, you think, okay, I understood. Then if somebody, what was it? Yeah, actually, why is like that? I don't know. So explaining to somebody else is a very good way to learn for yourself. Okay? So that's it. Okay? So in summary, there are going to be the seminaries starting in after, so May is free, so it's all going, the lectures are going to be only in the morning. We are going to start in June in the afternoon, after lunch, as you've seen today. We're going to meet here. You are going to give talks yourself, and each of you is going individually, according to the performance of what you presented, how you presented, but I give less weight to that. I give more weight to the meaning of the stuff that you're going to present and your critical view of what you're presenting. The result is going to be your mark for the exam, okay? So there is this sort of pressure on you, which is the pressure that you might have also when you explain to the community your results, okay? Because you feel judged by the people because they're trying to understand what you're doing, okay? So if you want, is the pressure that you have also in real life. Be careful when you present your presentations because it takes time, okay? You understand the paper, you master it, but to write the slides or to prepare your notes, it will take a couple of weeks at least, okay? Do it in pairs, try to do it in even 3 people together, help yourself, okay? But talk with somebody else, because if you're talking to somebody else, you are already talking, as I said, and this helps you already to structure the presentation, okay? You see what is important and what not. By talking, this is helpful, okay? So please do that. But again, the presentation, you do it individually, one after each other. They will last 25 minutes, and then there might be 5 minutes of questions from me and from the audience. Because again, you are explaining not to me, but also to me, I want to learn, but also to the others, okay? So you are explaining and they want to learn, therefore they will ask you stuff, okay? And also how you respond, you don't need to know everything, so you can also say, I don't know, Also, that is part of the evaluation. Okay, all the package, let's say, is going to be that. To choose your topic, I'm going to post a doodle where the topics are listed, and you will need to put your name. Okay, put your name, first and last name, such that and if you can, your matricle, so that we have everything under control. We don't make mistakes. With the date of your choice, are going to be again the Fridays after lunch, and the first one who put the name wins. Okay. So that's the selection, and then I'm going to post as well the literature that I'm suggesting that you can use as a starting point, and then use ADS or the archive to look for other papers that might help you to understand better the topic. Okay, and it is mandatory to be there. Okay, so Friday is not yeah, this guy is giving a talk. No, it's important. You have to be there. Okay. Good. So we'll make a list with your names, and you can tick it when you enter the room. Okay, so that we can keep track of that. Okay. Again, if you cannot attend for some reason 1, 2 times during the semester, just let me know and we can arrange it. The other thing is that I could do is that whenever you have presented your presentation or the papers that you want to study and to present, perhaps it might be useful if you first let me know, okay? So that I can go through it and just give you the first, just a first impression, and yes, go for it, or yeah, this paper, take care of this or that aspect, okay? So you have a little bit of guidance on that as well, okay? And we can do that via email, and just as it comes, okay? Good. Registration, so I will register the lectures in the morning. That's because I'm talking, I can be on the web and so on, but you cannot, okay? So I'm not going to record, as I mentioned earlier, your presentations, okay? So you must be physically here. In any case, I encourage you to come physically here also in the morning, okay? So that we can a little bit interact if needed. Okay. Good. That's it for today. I think we are done. Are there any questions?
As is like one talk for 2 people, or is
2 talks. Right, 2 people, 2 talks.
In the one Friday.
Well, I mean, we are going to have 2 hours, okay? So there might are going to be anyway. We keep no more than two talks, okay? The rest is for us to chat or to go away earlier, okay? So it depends, and then maybe there are going to be more talks in one day because oh look, all the other slots are taken and the other date I cannot. Then we can make also overlaps of this sort, okay? But ideally if we keep 2 talks. Per day, this would be ideal. Okay, yeah.
What would you recommend for reviewing papers effectively, so to find the useful papers?
Well, one criteria is the quality of the English, okay, because there are papers that are already written bad from a linguistic point of view, which means they were too fast in putting down the results, and this can happen. The structure of the paper, if it starts to be confused and confusing, then again it goes in the direction it was done too fast. Okay, look if each step is explained in detail. If they did something, it should be clear why they did it. So they can say we did this and that following I don't know, Maturi et al. Or whatever et al. Paper. Okay, so they are basing that step on somebody else's work. And then you can choose, look in the paper if it's true that what they did is explained there. It can happen that what they did is not explained there. Okay? It's rare, but it can happen. Or otherwise, it has to be explained. So there must be, if they are choosing certain parameters or a certain model or whatever, it has to explain why. So if you see holes or non-clarity in the methodology, then this might be a hint of bad quality for the paper, okay? And sometime, I mean, I've seen this happening only once, but it was a big collaboration it was about CMB observation and the polarization observation of the CMB, big collaboration, and one of the things they used was to build up their arguments was on data, which was private from another collaboration that they needed to complete the overall picture. It was private, and they took a picture from the slides that were presented online, that were presented in a talk, converted the colors in the pictures into numbers using the color bar, okay? And then they used this sort of data to continue with their research, okay? They arrived at their conclusion. There was, again, big splash, we found blah, blah, blah about inflation, press release and blah, 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 and then you read the paper and say, eh? And in fact, the result was completely false. I mean, because, take a picture with the color scale was falsified, and then that's not how you do it, but they wanted to do it because some other observations were coming online, they wanted to be the first, and they pushed it, okay? But they exaggerated. So this sort of thing, I've seen this happening once, but, this sort of stuff can happen. Okay, so quality of the data, if the quality are sufficient for what they're doing, because if they tell you, like, we used 500 supernovae, and they're scattered across the entire sky. And with these 500 supernovae, we are investigating if the universe is really homogeneous, because maybe the acceleration and expansion is faster in one direction with respect to the other one. Why not? That's legitimate. But you have 500 supernovae. What do you do? Where do you go? Okay, so are the data sufficient? Yes, no. Okay, so you need, with that, to develop this sort of judgment, you need experience also. But these are the things that helps you to spot if a paper is worth or not, or if it is too extreme. So if they arrive at whoa conclusions, then want to be extra careful. Okay, whoa conclusions need extra whoa care. Okay. Yep.
Does every person do one single topic, or do two people do the same topic and then have two different talks on the same topic?
It's up to you. I leave it to you. So you can work with somebody else. Maybe this other person is working on a topic, this other person on a different topic, but you interact. No, you interact, you discuss together and what to do and what not. Okay. If it's the same, it's easier because you are both pushing the same direction. No, so that this will be easier. But do it as you want. Okay.
So do like one aspect of the topic first, and then one different aspect second, and one person does the first.
Yes. Yes, that's an example, or could be even two different topics, and you just give two different topics, but you help each other. Okay, I leave it, it's completely to you. Yeah?
Does that mean, like, if you're working in a pair, two of the people can give the same topic?
Yes. Yes. Yeah, I mean,
Check the same topic for you.
yes, I mean, if we're saying Sunyaev-Zeldovich effect, there are, theoretical ways, observational ways, different instruments, different methodologies. So, there is one topic, it means a lot. Basically, would fill up a semester if you would like to go carefully through each of one, okay? So that's why I'm stressing the fact, be selective. You have to find really what is important, because each topic is huge, it's something on itself, okay? It's a field on itself. So you need to select carefully and really find out what are the relevant points. So within one topic, I mean, even all of you could work on Sunyaev-Zeldovich effect or cluster cosmology. Okay, there would be no overlap. So each topic is very broad. Okay. Good. Happy? Satisfied? Okay. Good. So we can finish here. So next colloquium is going to be in 1 month. Okay, so we can cover a little bit of topics during the lectures in the morning, and you have time to see what you want to do with your topics. Okay, so I will first publish the papers and the list of topics so that you have some time to go through the paper and so on and so forth. And I don't know, in a couple of weeks, I will open the doodle. So once you have done your mind on the topic you want to do, I will open the doodle on such that you can choose. Okay, you can express your favorites. Okay. Okay, good. Then, thank you very much, and I will see you next time, and next Friday.
I wanted to ask because I arrived 10 minutes after. There
Yes.
was something important at the end or something.
Wait, where is it now? I think this one. Manage it. No, topics. Here. So that's the next first seminar will be on the 7th June. So that's the first Friday. And I don't know, here? Yeah? Or I don't know, what was it about?
I was not the first 10 minutes. I don't know if there was something important said.
Well, I mean, the most important thing is that you need but I repeat it also later, that you need the seminar to pass the exam. That you must attend the tutorials, sorry, the tutorials, the seminars, and yeah, that you have 25 minutes to speak.
Nice work prepared. So this is the seminar from the course, and then there's going to be also an exam after.
No, your presentations of your talk, the talk that you are going to give, is the exam.
Oh, okay. And then you can go back to the goals, develop skill. Okay.
This one I will share it. So.
Yeah. I wanted to ask because I think I asked you via email for the material from Cosmology because I couldn't attend last semester. So I wanted to know if the topics. So I've been learning by myself the Cosmology. So I'm going to use these weeks of April and May. From the topics that are going to be given for this seminar, also like if there are some topics that have like I don't know, like they base on that. Yeah, I suppose they're going to use the theory of cosmology, but not like the last topics of the lectures, and they're like I don't know, like the basics or the first half. Is there something like that?
Well, mostly because we're going 1 month of lecture, so I'm going to cover all. I mean, several topics, but not all.
Yeah.
Okay. It doesn't matter. I mean, at that point, you should be able to basically manage all topics. I would say. I mean.
Okay. I mean, even though one is doing also, I mean, because I'm also doing parallel also by myself the theory of cosmology, also from the last semester. So you think it will like work?
You can try. I mean, I gave basically I'm giving like an overview of the aspects of cosmology that one has to know. There you should see how far you are from what is needed. Okay.
Today, tomorrow, in the morning.
Not in the morning. So this morning and then next Friday in the morning, I'm going to basically complete, I hope, the basics of cosmology that one needs to know. And there you see, okay, this I can learn fast or not, or what the hell is this? I have no idea. So you can.
Okay. And yeah, one question last. Also, like the lectures in the morning are going to be recorded, right?
Yes.
But also like it's from here, but also like one can like also remote see them?
No, not. I recorded and then I post them on,
Like
on
after
YouTube.
it.
So after the lectures, you.
Okay.
Yeah.
Thank you.
Okay, welcome.
Matteo, can you send me the list of paper? Because I'm not registered in the...
Yeah, sure. Okay, I will. Okay.
But
Ciao.
I just want to ask if we happen to find some other interesting topics, can we propose that?
Sure.
Okay.
Yeah. I mean, it's total freedom. Mine are suggestions, and you can take them as a starting point. But then you can, if you're interested in some specific topic, why not? Right. Okay. Great. Welcome. Bye.
Sorry if I don't want to take too much time.
No worries.
Okay, thank you. So first I want to ask, so you said we should plan probably 2+ weeks to do it. Do you know, or could you estimate how many hours it was? Well, I would think I would start maybe even before that, so 4 or 5 weeks in advance.
How much time?
But, it probably was more, but then again it wasn't that, like, the matter was not that complicated or not, it was more delving into new topics. So.
I mean, it depends. It depends how close you are to the topic, and I mean, with the 1 2 weeks, I mean, the 2 weeks or more, I mean, just to make the slides.
Okay.
So that's the starting point.
Okay,
Before you have the papers, you go through it, and once you're there, you know that you will need a couple of weeks.
Yeah. Okay. That's what I was.
Yeah.
Then I wanted to ask what. So 2 questions about artificial intelligence. So one was, so how do you include? So I think you already include machine learning in your, but do you already include like large language models? Do you use like GPT-4 or?
No. It's not. No, it's not. It's not going to be about. I don't know how extended it's going to be because they introduced it last year, and the lectures are quite packed. And last year they were in two to give the lectures, and one was a specialist in data mining and machine learning. So I'm going to do it a little bit. I will shrink a little bit this part, but I'm going to explain, for example, what are neural networks, what they are, convolutional neural networks, and this sort of architectures, but not tools like ChatGPT or
But do you use them already in research? GPT-4?
I mean,
for coding probably.
It is crazy. It works well. Yes.
Yeah.
It works well.
So what do you experience that it's really helpful?
Yeah, if you need to translate codes, it's great because it spares you a lot of time. And if you have, I mean, I kind of, usually you use Google because you say you need syntax or something, but then you put it in ChatGPT and you get the snippet of the code. So this is helpful. The codes have to be checked because you cannot trust it.
It's about the possibility of course, you have to be very diligent and careful about what it gives out.
Yes.
But I was also wondering about the possibility to instruct such agents, like chatbot agents that run on models like GPT-4 or in the future even more powerful, to instruct them with the data that one uses for research and maybe talk about the data directly with a maybe more capable agent or like in terms of computing.
This would be a bit of a stretch.
It's not yet
because keep in mind that machine learning, they are just models. They are models with 1 million parameters or more, okay? And these are a lot of degrees of freedom. And if you are adding even other degrees of freedom, then the things is starting to be complicated. But there are architectures that are kind of a combination of various different methodologies. And then, according to the data in the training set, if it's a supervised learning, then the method identifies which one is the most efficient method. But there is always the risk of overfitting. I mean, it's a dangerous business. It depends on how machine learning is used.
I was wondering what the other part is that if large language models, if they maybe approach general intelligence, will they be able to propose or to help with coming up with new ideas for research? Or?
It depends how new is your research.
Okay.
So, because if it's like we are doing a study with you have a set of galaxies and I'm studying the correlation function or something like that, okay? Then it was done by 10, 20 other teams, you have your new data, and then you can ask what to do, and then according to your data set, maybe if all data are available, the agent could choose among the other methodologies used by others, which one is the most appropriate to you. Okay, but if you're doing something new, then I don't know.
Much speculation.
Yeah.
I want to ask you something personal, because it's maybe a bit overwhelming for me to confront with just going through that many papers. I want to ask how many papers do you usually read per week or per day? What do you have to read?
Oh, it depends on the period, because sometimes I don't have the time to read other papers, but I have to go to, for example, in Euclid, I typically get 2 or 3 papers per week that I have to read. But, that's part of my task, and I have to read them. And there you have to be careful, because you're kind of reviewing, and it takes time. But for the literature, typically it should be less than an hour. Because 1 hour every day, in a week is like 5 hours. It's nearly 1 day of work.
Yeah.
So
shouldn't take too much time.
No, but there is like Cosmo Coffee is a portal that you kind of say what are the fields that you're interested in, and then it makes a ranking for the papers. So you have a first one closer to cosmology or what you do, and then I don't know, you go down to plant formation or whatever, or comments.
I think that also maybe not similar, but also pages, applications that work on such large language models that are used for finding research papers, or to if you
like
have a certain topic in mind or a connection to another topic, then you go into this application. I don't know. Something like that.
I don't know that one. I've seen one which is based on is sociologically based, because people are touched, they're expert in something, and therefore the name of people is attached to a scientific question. And in the paper you have the network of all the interlink between different people and different papers. So you can say, I like this and that author, and then there is the cascade of other papers that are citing these people, and which means they are close to that topic, and therefore it creates a sort of sociological network, and it works pretty well, I would say. And it is again a way of sorting the papers.
Is that the strategy?
No. It's actually quite old. I think it's 10 or 15 years old.
Like Google Scholar?
No, it's no, I don't remember what it was called. Archive Sorter, I think.
I think I was thinking about. I don't have my name. Maybe I'll write you.
You mean
remember?
it's like an active search.
Yeah,
I'm interested in this.
It's something read about in the presentation talk. Something about that. It came out recently with the search of these large language models, and then.
It would be interesting to
maybe we can show it.
No, it would be great. I can share it also with the others and see what's their experience. Otherwise, if you do it by hand, you have your paper, then you have the references, you want the references, and you have this connection there. You can look into the subject.
Of course, one has to be careful to see how good it works and how good it is.
Yeah.
Always fits.
It's a filter.
Okay.
Thank you. Bye. Ciao.
I want to make a small question. Since I'm learning by myself, I found this script that actually I think it was made for mathematicians. And they something from Cambridge or something like that. And it's like music, right? And that is which already like the beginner, because it doesn't make so much sense. It's like about this cosmological principle, and they say about homogeneity and isotropic.
Yes.
If something is homogeneous, is it already isotropic? Because if it looks at every point the same, then it's going to be looking in every direction the same.
I mean, the two are related, but they are stating two separate concepts. Because, for example, homogeneity, it might be also basically you have the same properties all over the places. Okay, and you might have like a vector field, which is pointing somewhere, but locations is always the same. Okay, so you see it would be homogeneous, but it's not isotropic because there is a direction.
Okay, that's I mean, like if for example, in every point, everything is like this.
Exactly, this would be not homogeneous.
But if I do it like this,
this would be a not isotropic. So if we have sticks that are all the same all over the places, the same density of sticks all over the places would be homogeneous.
Yeah.
But it's not isotropic.
Yeah, because if I see it from here, it looks like this, and if I see it from here, it looks different.
Exactly.
And from here also, with this inclination, and from... okay. That makes sense. Okay, thank you.
Ecco.